This is my submission for exam 2 for advanced math topics for middle school teachers. Find formulas for a, b, and c such that you can plug in any natural number n and find a, b, and c that are side lengths of a right triangle. In particular, side b must be 5 units shorter than side c. In order to start finding our equations, we will draw a square. This square will be c by c, showing c squared, and then we'll draw a smaller circle on the inside, or laying on top of it, as b by b. Since we know that b is going to be 5 less than c, we know that this length up here will be 5, and this length down here will be 5. Looking at this, we know that this rectangle up here will be 5b, this small square in the corner will be 25, and the rectangle right here will be 5b. So we know that a squared equals 5b plus 5b plus 25. In other words, 10b plus 25. Now we want to get b by itself in order to find our equation for b. So we have a squared minus 25 over 10. And that's how we find b. Our next step will be we'll have to find a. And we have to find a by looking at what can we plug in for a into the b equation so that it will work out that b will be positive and c will be positive. So we know that a will have to be greater than 5. In other words, n, when you plug n in to the a equation, it will have to be greater than 5. So I came up with the equation a equals 10n plus 5. This way, any n integer that is whole will give you a number for a that will work out as a Pythagorean triple. If we use the equation up here, down here, we get our three equations, a, b, and c, as a equals 10 plus 5, b equals 10 plus 5 squared minus 25 over 10, and c equals 10n plus 5 squared minus 25 over 10 plus 5, because we take the b equation and we add 5. The next part is to use our formulas to find the Pythagorean triples for n equals 1, n equals 5, and n equals 10. So I already have them written out here along with some other numbers. For n equals 1, we would plug that into right here, so we get 10 times 1 plus 5, which would give us a, 15. We then plug a into this equation, and we would get 60. And then we just have to add 5 to b to get c, or if you want to double check it, you can plug b back in to this equation, or n into this equation, and you can plug n to this equation too to get b, or you can just add 5. So our Pythagorean triple for n equals 1 is 15, 20, and 25. And we'll do the same for 5 and 10. For 5, we do 5 times 10 plus 5, which is 55, and then you can plug n into our b equation and c equation to get 300 and 305. So our Pythagorean triple will be 55, 300, and 305 for n equals 5. And finally, for n equals 10, we'll do the same thing we've been doing with our equations. You'll get a equals 105, b equals 1100, and c equals 1105. Our final part is to prove that Bloch Pythagorean works for the Pythagorean triple where n equals 5. So like I said in the beginning, when n equals 5, n will equal 55, b will equal 300, and c will equal 305. So we will draw our triangle of a, b, and c and label each circle, draw a circle off each side and then label them as so. Then we will use our diameters to find the area of each circle, which we know is pi r squared. So we will take a half of each of these diameters to get the radius and then plug it in. We will then take the area of a circle and b circle and add them together to prove that those will add up to the area of c circle. So circle A is equal to 2,375.83, and circle B is equal to 7,685.83. Add those together, you get 7,361.66. And if you take the area of circle C, you will also get 7,361.66, which proves the Bloch Pythagorean theorem works.